So we have shapes, and we're trying to find the areas of these shapes. We're trying to find the areas of the shaded portions or unshaded portions, depending on the question. We're going to start with the first one right here. If you look at this closely, you realize that you could divide it into two different shapes. The top and the bottom. They are both trapezoids. So you can say trapezoid A and trapezoid B. You have certain numbers that you can work with, and you can go from there to solve all the problems. So let's start with the first one and see how we can solve this. In terms of x, if someone told you to solve this in terms of x, all you do is write out the area of a trapezoid. That's the first thing you need to know. Area of trapezoid. And that's simply half base 1 plus base 2 height. And so we take this and we take that equation and we plug in the answers, or the numbers. We'll call that our base 1 for the first trapezoid, and we'll call this B2. 4 plus 6, these are 6's. Sometimes they don't give you all the numbers you need. You need to be able to figure out what number would go there. So 4 plus 6 plus 4 will give you 14. And then you have, so that would be your B2. We'll call that 14. So we have half times 6 plus 14. And then the height is 8.5x. So that simply becomes half times 20, we have a 10, and then we have 8.5x to work with. We have 6 plus 14, which is 20, and then we have 8.5x minus x. That's what I was going to check. Minus x, and that's the height. By using distribution, we know that 10 goes in and it becomes 85 minus 10x. But notice that that's the area for the top. We'll just call it AT for now. Area for the top. To find the area for the bottom, we do the same thing. It's half times, and we have 4 plus 6 plus 4. So we have our 14 again. So 14 plus 6. This is also 6 on the bottom. So half times 14 plus 6 times the height, which is x. So here we get 20 over 2 times x. And so we get 10x for the bottom. Area for the top was 85 minus x. Area for the bottom was 10x. If I tell you to find the area for the figure as a whole, it will be 85 minus x minus 10x plus 10x. And the answer is 85. That's how you do the first one. Again, remember, you need to know what the formula is. Formula is half b1 plus b2 times height. And you use that to solve for the top. Then you use the same thing to solve for the bottom. And you add the two together. If they tell you to leave your answer in terms of x, that is what you should get. 85 minus 10x plus 10x. But notice that if I tell you to simplify it to the end, the answer will be 85. That's how you do number one. Number two. When you're solving the area for a figure like this, you need to acknowledge that there's three figures you're dealing with. You're dealing with triangle A, triangle B, and the area, the semicircle, which has a diameter of 20. Notice that these are equal, and these are equal. Now, we might have everything we need, or we might just have some of it, but we're going to work with what we have. When you want to find the area of a circle, use pi r squared. So we have pi times 20. Well, we have the diameter, so we're going to say pi times 10 squared. So we have 100 pi for the area of the circle. If it was a circle, that would be it. But now, of course, it's a semicircle, so we divide that by 2, and so we get 50 pi. Now we go ahead and find the area of the triangles. Half base times height. We have the base. This is 10, and that is 10. And then we now look for the height to solve the problem. In the book, it gives us 30 for the height. And so all we need to do is use half base, which is 10, times height, which is 30. And that gives us the area for the first triangle. And so that simply becomes 150 centimeters squared. if we're using cm as our unit. And so we have 150 for the first triangle, we'll call it T1, plus 150 for the second triangle, plus the area of the circle. We add those three together, 150 plus 150 plus 50 pi, and that gives us the area of this one. I want you to work on that and give me the answer to that one. So the area of the first triangle is 150, the second triangle is congruent to it, and then the area of the circle was 50 pi. So why don't we do that? We'll stop there for now with these two examples.